Hi. In this video, we are going to cover identifying missing values, recoding those missing values, and then using a loop in order to be able to recode multiple variables in the same way, all using Stata and specifically using the General Social Survey to look at these processes. And so for this example, we will be working with Stata 16.1. And again, like I said, we will be using the General Social Survey in order to look at these different procedures within Stata. And so first things first, pulling in the information from the data file into Stata. And so we see here the data file has been pulled in. I've got my variables showing up here, information about my data file down here in terms of the data file's name, GSS 2016, number of variables, number of cases, its size and memory consumption, all that good stuff there. So great, we've got our data pulled in, wonderful. So for today's example, the 4 variables that we are going to be looking at are variables asked of respondents having to do with sort of attitudes towards freedom of speech. And these variables have been asked for a long time, and so it tracks sort of changes or changes in attitudes towards questions around free speech. And so these variables, specifically SPK-HOMO, SPK-MIL, SPK-ATH, and SPK-RAC, are asking whether or not the respondent believes that a homosexual should be allowed to give a speech in their community, a militarist should be allowed to give a speech in their community, an atheist should be allowed to give a speech in their community, and finally, if a racist should be allowed to give a speech in their community. And so we can just start by simply looking at our variables and running a frequency distribution to do that, using tab 1 to run multiple variables at one time. And so we see here our items. Again, should you allow? Do you think homosexuals should be allowed to speak in the community? A militarist, an anti-religious, sort of standing in for atheist, and then finally a racist. And so within each of these, what we're seeing, we see the variable value distribution here, values of 0 allowed, not allowed, 8, 9, and we see this repeated, 0 allowed, not allowed, 8, 9. And so all of this pretty straightforward in terms of the allowed versus not allowed, but one of the things we see very quickly is we have these other values, 0, 8, and 9, and it's not really clear just looking at Stata, well, what the heck do these variables mean? And so there is actually a little bit of research for us to do to try to figure this out. And in particular, we can do that by visiting the General Social Survey codebook to try to look and see, will it give us a little bit more insight in terms of what these values of 0, 8, and 9 mean. And so I've pulled the General Social Survey codebook in, going to the website, gssnorc.org, and then grabbing the codebook there. And so here we see a very large codebook, over 3,800 pages worth of information. And so we can pick just one of these. Since we're going to be using the variable SPK RAC for the next little bit of this example, we can just start here and use that variable for our purposes. I'm going to use the Control F feature to be able to search for it. And so SPK, and then again, RAC. And lo and behold, here we see that variable being asked. Do you allow a racist to speak? Do you think a racist should be allowed to speak? Well, this is giving me the variable name and the variable label, but what we're interested in is in the value labels. What does that 0, 8, and 9 mean? And so I'm just going to forward along in the data codebook, and lo and behold, okay, here we go. So this next one here, what we're seeing here is the question, the literal question wording. And so the question wording here is a person who believes blacks, African Americans are genetically inferior. So a racist, if you will. And so the question here becomes, if such a person wanted to make a speech, if a racist wanted to make a speech in your community about their views on race, should he be allowed to speak or not? And so we see here that a value of 1 is yes, they should be allowed. Okay, so this allowed value is a 1. We see that 2 corresponds to not allowed. So this 2 value, this not allowed value is a 2 over here. And now we're seeing our other values. 8 is don't know, 9 is no answer, and 0 is not applicable. Okay, so now we're getting some insights here about what these different values mean of 0, 8, and 9. one thing that we have in common across, so they do mean different things, but one thing they do have in common across them is each of them pointing us to something about how this is a perhaps less than valid value, a missing value, in other words. And so, okay, I'm going to drag the code book back out now that we've gotten some further insights in terms of what's going on here. So now that we know what these different values mean, we can go about trying to recode them and sort of letting Stata know, because right now what Stata's saying to us is this value of 0, 8, and 9, it's just like, yeah, it's a 0, it's an 8, and it's a 9. But what we've just figured out is that while those values do have meanings, they all generally collectively mean missing, a data point not worth sort of analyzing, or perhaps not worth analyzing. And so with that in mind, what we're learning here, Stata does not realize they're missing, and so we need to help Stata understand, yes, these are missing data. And so for that purpose, we can recode the variable. And so that's what we're doing here in our command. Or in our code, we've got the command recode. We are specifying the variable that we would like to recode, in this case, SPKRAC. And then we're telling Stata how we would like that recode to take place. Specifically, we're saying, please take the old value of 1, make it into a new value of 1, call it allowed. Take the old value of 2, turn it into the new value 2, and call it not allowed. Then, and here's our handling of the missingness, take the value of 0, 8, and 9, and set it equal to period. And in this case, what we're doing is we're handling missingness by setting all of the missing to system missing, which in the case of Stata is handled by a period. We are then specifying within Stata for it to generate, that's what the GEN stands for, generate a new variable, which we are specifying here within the parentheses, which we are calling SPKRAC underscore miss1. And I'm calling it underscore miss1 because in a few more moments, we're going to actually create another missing value recode that I will label miss2. So this is just helping me understand that I have 2 versions of this missing data recode. And so, okay, this is the code we want to use to recode our variable SPKRAC. So I've selected the code, I've run it, we look over here, we see that the code has run. We aren't seeing those dastardly red letters that we want to avoid, the errors, if you will, that Stata throws at us sometimes. And so, okay, but we don't see much else happening. And in fact, if all I did was look here, this is all I can see. And you know, I'm a little nervous perhaps that maybe this didn't quite do what I thought it was going to do. But in fact, if I really want to check to see like, hey, did I actually create anything, Stata is going to tag to tack on at the end the new data variable that was created. And so we could go over here to the variables box, grab the scroll bar here, and just pull it all the way down to the bottom. And indeed, what we see here is our newly created variable SPKRAC underscore miss1 is there. And so, okay, wonderful. We've got our new variable. Now it's time for us to check and see, well, you know, what does that new variable look like? Did it do what we thought, what we wanted it to do? And so I'm going to select this row, run it in order to get the frequency distribution. And so we see here a frequency distribution where we get the values of allowed and not allowed as the output. Okay, good. You know, one of the things we wanted is we wanted to be able to identify those who responded, yes, they should be allowed, or no, they should not be allowed. And so that seems to be what happened here. But what we'll notice is we went from 5 categories, 0, allowed, not allowed, 8, 9, to 2 categories, allowed, not allowed. Well, what happened to the other 3 categories? Did Stata drop them? Did those cases go away? Well, no, Stata didn't drop them. Those cases didn't go away. They're still there. But what Stata is doing is it's now acknowledging, hey, I recognize that those are missing data points. And so I'm not, this is Stata, I'm not going to report them as my default, but we can ask Stata to go ahead and report them just to confirm for us that indeed they are still there. And I do that by adding this word missing on the end of my tabulate command. So here I've got the exact same code one more time, but I put a comma missing after it. And now what I'm doing is I'm going to run a frequency distribution again, but this time I'm saying, please report any missing data that might be there, any data that Stata recognizes as missing. And so when I do that, I now see my first two categories are the same, allowed, not allowed, but there's now this third row over here, this period, and associated with this period is a value of 1004, suggesting that there are 1,004 cases that have been set to system missing. Okay, so the cases are still there, but Stata now recognizes them as system missing. Then as a final check, and then this is, we sort of already started to do this, but this is just calling direct attention to it, we can take a frequency distribution of our original variable as well as our recoded variable and use that in order to compare, did we actually do what we thought we did? And so here I'm gonna run one more time, frequency distribution of our variables. We are interested in keeping the allowed and not allowed group. That's what we see down here. And most importantly, we see that allowed was 1136, allowed 1136, not allowed 727, not allowed 727. So indeed, this does appear to have done what we anticipated it doing. And for the interested researcher, if they took 977, 20, and 7 and added it together, it is going to equal the 1004. And why does it equal the 1004? Well, because we took 0, 8, and 9, and we set all of those equal to period. Again, that was what we were doing right here in our code. And so that's why those values sum to this period. So, okay, well, now we see how we could handle missing data. This is all well and good, but what we've done in this process of setting all of these values, 0, 8, and 9, to system missing, is we've lost some information along the way. So you might be thinking to yourself, well, it's all missingness. What do you mean we've lost information? There are circumstances under which you might not want to simply just collapse everything into system missing, but rather still retain some of that information about types of missingness. And in particular, we can think about the GSS as a perfect example of this, where we have the different values, 0, 8, and 9, meaning very different things. 0, as we've determined from the code book, is not applicable. What does not applicable mean in the context of the general social survey? Well, brief history on the GSS is they're trying to ask all these different questions. And one of the things that they appreciate, though, is if they asked every question of everyone, their survey would take forever to complete. And so to try to minimize the burden that they are placing on any single respondent, they create modules every year where they ask a set of questions within each module. And I think that it's roughly about 3 modules that they have. And every respondent, generally speaking, will get 2 modules. And so what we see over here going on is that this variable, SPKRAC, was included in one of the 3 modules. And so this 977 essentially represents those people that did not get these modules, this module. These are the people that simply were not asked this question. Okay, so a 0 is not applicable, meaning the person was not asked the question. In contrast, a value of 8 and a value of 9, as we learned earlier, 8 is don't know, and 9 is a no answer. Well, so these are folks that were asked this question, but rather than being able to pick a allowed or not allowed response, they opted for something else. And so there might be circumstances in which knowing that additional piece of information, in other words, knowing that 20 people said don't know and 7 people said I would prefer not to answer, may be useful to a researcher, and in fact could be the primary concern or interest of a researcher. If I was interested in attitudes around ambiguity towards this question of, or towards questions of freedom of speech, if I wanted to know something about ambiguity and freedom of speech beliefs, in fact, all of a sudden, number 8 and number 9, response option 8 and 9, become my most important responses. Well, if I take 8 and 9 and 0 and collapse them all into a single value, well, I lose the opportunity. I lose the ability to actually tease that apart. I lose the nuance in my data. I lose the information. So there are circumstances where we might want to retain some of this information, but at the same time, we still want Stata to know, hey, these are kind of sort of missing data relative to our 2 main categories of allowed and not allowed. And so that is the second pass of missingness that we're going to look at. And so here we have some new code. I guess it's the same command, recode, but we're gonna use it a bit different. So sort of a bit of a new way of looking at it. So here we have our command, recode. Again, we're gonna recode that same variable, spk-rac. And we're doing some similar stuff again. Old value of 1 is gonna be set to a new value of 1. We're calling it allowed. Old value of 2 is set to a new value of 2. We're calling it not allowed. And then old value of 0, and here we're going to get into some new territory. An old value of 0, we are now setting to period A. Period A is telling Stata, the period is telling Stata, hey, this is a missing value. And the A is now telling it, but it's a particular type of missing value, or at least we are going to have multiple types of missing data. And in particular for this one, we are going to call this 0, which we are converting to period A, we're going to call this not applicable. A value of 8, we are going to set to period B, we are going to call that don't know. And a value of 9, we are going to set to period C, our third type of missing data, and we're going to call it no answer. And then to finish off this code, we have our comma, and then we're going to generate a new variable, and we're going to call that new variable spk-rac underscore miss2. And this is our second iteration of the missingness variable. All right, so I'm selecting this command. I'm running it. I'm looking at my window. I see once again, okay, no red letters, no yelling at me on the part of Stata, so my code seems to have been accepted. That's cool. If I wanted to sit here and see like, okay, well, did it really do anything? I can go back over to my variables box, grab my scroll bar, pull it all the way down to the bottom, and whoop, lo and behold, spk-rac underscore miss2. So, okay, I've created a new variable, and now what we want to do is we want to look at it and say, well, did I create what I think I created, what I intended to create? So I'm going to run a frequency distribution to start out with, and here we see this code tabulate with a variable next to it. I'm running it. Lo and behold, here we go. I've got my frequency distribution, allowed, not allowed, but again, it's just those 2 responses. We know from before there were 5 original categories, so they've gone somewhere. Those other 3 have gone somewhere, and you know what we're hoping is that they've gone into this missing space. But Stata is not going to report that missing value for us, intuitively at least. And so we need to ask Stata to give us that information. And so we're going to do that by putting a comma missing. So this is specifying, hey, Stata, I want you to report these, any missing values that are there as well. Please go ahead and report those. So I'm running this code, and there we go. We're seeing them again now. So we've got our allowed, not allowed. We see now not applicable, don't know, and no answer. Okay, cool, great, wonderful. So they're still there. Those cases weren't dropped. This is good. And so then the last check that we want to do is to, again, compare our original variable with our newly created variable to make sure that our coding stayed consistent. And so here we go. We have allowed 1136, allowed 1136, not allowed 727, not allowed 727, 0, which we remember is not applicable, 977, 977, don't know is 20, 8 was don't know, 20, 9, no answer is a 7, no answer, a 7. And so what we're seeing here is that as we wanted to, our recodes have worked. We've taken our original variable, we've set the certain values to missing that we wanted to set to missing. In this case, we've retained some additional information about what different types of missingness are contained within our data. Not applicable, don't know, no answer. Maybe we'll use them, maybe we won't in subsequent analyses, but at least we still have that information. In contrast, if we had just set everything to system missing, that information is gone. And so this is all well and good. This is exciting. We've done this recode. Congratulations. But if we recall, this example that we started with 4 different variables. And I'll run really quick the frequency distribution of these again, just to sort of maybe drive home a point that's going to help us launch into this next and final part of the video, looking at looping. And that has to do with the fact that when we look at the variables, SPK-HOMO, SPK-MIL, SPK-ATH, SPK-RAC, we see that each of them has the same variable structure. 0, allowed, not allowed, 8, 9, 0, allowed, not allowed, 8, 9, 0, allowed, not allowed, 8, 9, 0, allowed, not allowed, 8, and 9. Now, why do I keep repeating that? Why is that important? That is important for us because what we now know is that the code that we have created already for the recoding of SPK RAC, we could essentially just take it, copy it, paste it, swap out a couple of different variable names, and run it again for each of these variables: SPK HOMO, SPK MIL, SPK ATH. And that's fine. That is one way of going about doing that, applying code across multiple variables. And you know, I mean, I guess in all honesty, with just 3 other variables, it is straightforward enough to do that. However, there are going to be some scenarios where you might be recoding a data set, and it's not 3 variables that you're needing to try to recode. It's 30 variables you're trying to recode. It's I mean, this may be a bit extreme, but 300 variables you're trying to recode, all of which have the same variable structure. So under those circumstances, the idea of copying and pasting and swapping again and again and again, all of a sudden maybe isn't quite as attractive as it is here. And so for those purposes, Stata has introduced what it refers to as the loop. Within the loop, what you are doing is you are specifying a line of code, and you are setting up a loop that will go through that code again and again and again for as many times as you tell it, as you tell Stata to go through that loop, applying it to certain things. And so we can look at some looping code here, starting on row 55 of our code, with this line, with the command, with the word for each. For each is one type of looping that Stata offers. And so what this code is doing for us is it is telling Stata, hey, we're about to loop. So for each of the var, and var is now creating a local, and we're seeing it here down below. So this is something we're making up, and we're just simply calling the local var. So for each var in the variable list, that's what the of var list is telling us. So this is for each var in the variable list, and then we're listing our variables: SPK HOMO, SPK MIL, SPK ATH. These are our 3 variables. So for each var in the variable list of these 3 variables, do this code. In other words, run this loop. The code is what we've already created. We are now just adapting it to take place within this looping framework. So we've still got our command, recode. We see now our local call, our local recall, var. So again, that's this right here, var. I'm applying here within my loop itself. And so what this is going to do is it's going to take SPK HOMO and put it right here, run loop 1. When it's finished with loop 1, it's going to take SPK MIL, put it right here, run it again, the second loop. Then, when it's done with the SPK MIL, it's going to take SPK ATH, put it right here, run it a 3rd time. And it would keep doing that for every variable you have in this list. In our case, it's just these 3 variables, so it's going to do it 3 times. But this is how you could get Stata to run through tens of, perhaps hundreds of variables pretty straightforward. Again, keeping in mind they do need to have the same variable structure in place in terms of their values. And so what are we asking for Stata to do each time? Well, we're taking the old value of 1, we're saying set it to the new value of 1, call it allowed. Take the old value of 2, set it to the new value of 2, call it not allowed. Take the old value of 0, set it equal to period A. Again, so we're gonna retain that code we used to specify our different missing values. So we're going to take an old value of 0, set it to period A, call it not applicable. We're going to take an old value of 8, set it to period B, call it don't know. And then we're going to take 9 and set it to period C and call it no answer. And in doing these things, we are now setting, so this is the same code we used before. We're separating out the different missingness. And so we want to finish this code with a period generate, and then we see that var one more time. at least in this section of the code. I got it down here again, but so right here we see the var again. And so what Stata is going to do is when it puts spkhomo here, it's also putting it right here so that it's going to create a new variable called spkhomo underscore miss2. And then when spkmil gets put right here, it's going to put it here as well and create a new variable called spkmil underscore miss2. And then just to drive home the point, when Stata takes the spkath and puts it here, it's also going here. And in doing so, it's going to create a new variable called spkath underscore miss2. Finally, as part of the loop, we're going to do our QC check. Again, we know the loop works. We're pretty confident that the loop works. But there's never really an issue with doing a little more QC, a little more quality control. So we're going to run our tab1 command here where we're going to look at the original variable. So again, when it's spkhomo, the spkhomo will go here. It will also go here. But by putting it both here and here, what we will be doing is running a frequency distribution of the original variable spkhomo and our newly created variable spkhomo underscore miss2. And it's going to repeat that for spkmil and spkath. So that is the loop. And this loop is contained within this opening bracket here on the first line. And it has said, okay, I'm done with the closed bracket here at the bottom line. So that is our loop. We're going to select the rows, keeping in mind for these rows, for a loop, you do need to select all of the rows at one time. Trying to run individual rows in a loop will get you those red letters that we talked about earlier. But here we've got all of the rows of the loop selected. And so we will go ahead and run this. And on the left side of the screen, in the blink of an eye, things flew by really fast. I'm going to scroll back up so we can go and look at this a little more carefully. All right, here's our loop getting fed into Stata, no red letters, so yay for that. And so now we get the tabulations, the tab1 breakdown. So we see the tabulation of spkhomo. This is our original variable. And lo and behold, we see our classic 0 allowed, not allowed, 8, 9, corresponding to 977, 1667, 195, 1513. Okay, so then our question becomes, did our recode work? And so down here we see allowed 1667, 1667, not allowed 195, 195, not applicable 977, 977, don't know 15, 15, no answer 13, 13. Yes, this recode worked. We're seeing these missing values down here because we asked for those missing values to be reported over here in our code by including the missing command right here at the end of our tab1 line of code. And so we can now go through and just do a quick check of the other two variables. So for the militarist, we can 1356, 1356, 505, 505, 977, 977, 22, 22, 77. Okay, that recode worked. And then finally for atheist, 977, whoops, sorry, the wrong category. 1493, 1493, 378, 378, 977, 977, 11, 11, 8, 8. Our code worked. And again, we sort of knew that this was going to work, seeing as how we had already checked it out earlier on one of the other variables. But this is a nice check one way or the other because it does allow for us to, in case we thought a variable had the same variable structure, but it didn't, what we would see is that this code would return some funky results for us. And so this is confirming for us, yes, indeed, these variables have the same variable structure the way we anticipated it would. We are seeing that our recode worked the way that we hoped it would. And so, okay, we've now figured out, we've now looked at how we could recode missingness. We've looked at how we could recode missingness to retain different types of missingness. And now we've seen how we can apply that recode statement across multiple variables, sharing the same variable structure using a loop within Stata. And so, yeah, at that point, you'd be off to the races, either recoding a little bit more, or in this case, I've got a save command. If we wanted to just sort of save what we've done here on the general sensor survey, we can run that and the data's done. But yes, so that is our example here of working with missingness, retaining different types of missingness, and running a loop using Stata. Thank you so much. I hope this was useful. Have a good day.